Hello to all. Welcome back to JP Physics Academy. This is Naresh Babu Javaji. Students, in the last video we discussed about the units and types of the units and the multiples and submultiples and what are those advantages of the submultiples and multiples, and we changed the values from one unit to another unit, means from picometers to femtometers, from picometers to megameters, so like that. Okay, so now today's we are going to discuss about the new concept that is very important for this MCET and from some other examinations, that is about the dimensions and dimensional formulas. Okay students, so let's go to the video. Dimensions and dimensional formulas. Dimensional formulas. Dimensions and dimensional formulas. Students, before we go to start this lesson, let me tell you a few words about this, the importance of this concept. So students, we may expect some questions from this region in your MCET examination. So in the MCET examination purpose, it is very important. Okay, so let's try to know about that basic things which are related to the dimensions and dimensional formulas. The next video we will go to discuss about the complete structure, means that what are the advantages of these dimensions and dimensional formulas with the proper examples and proper problems. Okay, now let's try to know the definition and some basic things which are related to the dimensions and dimensional formulas. So students, first of all, sorry, dimensions. What do you mean by dimension? What do you mean by dimensions? How do we define the dimensions? How do the physics gives the definition of the dimensions? So, friends, sorry. Dimensions means is nothing but the powers, the exponents of the physical quantities. Okay, students. So, actually, the fundamental quantities, we know that fundamental physical quantities. What are those fundamental physical quantities? And we have the 7 fundamental physical quantities. First one is that mass, which is represented by m, and second one is length, which is denoted by L, and third one is time, which is denoted by capital T, and the fourth one is temperature. As you all know all those things, students, just we should know all these things. After that only we can understand about the dimensions and dimensional formulas. Okay, so temperature is represented by K or theta also. Okay, or theta. The fifth one is current, which is represented by A for ampere. So, or some textbooks we can see that current is represented by capital I also. And sixth one is luminous intensity. Luminous intensity, which is represented by CD, means candela is the unit of the luminous intensity. That's why we can represent this luminous intensity is by CD. And the seventh one is amount of substance. Amount of substance means, students, this is nothing but a matter. Okay, na? Then amount of substance is represented by mole. So these are the general representation letters of this respective fundamental physical quantities. Now we are going to discuss about dimensions. So means that dimensions means whatever the powers which are situated, which are located at each and every physical quantities, that powers, the exponents, we are calling as the dimensions. Okay, students. So how do we define the dimensions? The dimensions of the physical quantities are exponents to which the fundamental quantities are base quantities. Whatever the powers which are the fundamental quantities, such quantities powers we are calling them as the dimensions. Okay, students. Then let us try to know about the dimensional formulas. Okay, generally the dimensions or the dimensional formulas are represented by that square bracket. Okay, na? For suppose area is there. For suppose area is the derived fundamental. So area is the derived physical quantity, which is the dimension formula of this area is L2. Okay, then volume. The volume is the derived physical quantity and its dimension formula is L3. So each and every dimension formula of fundamental physical quantity can be represented by this closed bracket or the square bracket. Okay, students. So for suppose force is there. Force is the derived quantity and M L T minus 2 is the dimension formula of the dimension formula of this derived physical quantity of the force. Okay, then let's try to know about the dimensional formulas. Dimensional formulas. What are those dimensional formulas? Students, the dimensional formulas means if we express these dimensions of these fundamental quantities with a suitable appropriate letters. It means appropriate letters means that the suitable fundamental quantities. Okay, na? For example, for example, force is there. Okay, what is the force general formula? Mass into acceleration. Mass into acceleration. So F is equals to ma. The F is equals to mass dimension formula is the m1 and acceleration dimension formula is the L1 t minus 2. So students, in this case what we understood is, in this case dimensional formulas means the dimensions which are represented by situated by the powers of the respective basic physical quantities are called dimensional formulas. The formula which is containing the fundamental physical quantities with their powers or with their exponents. This equation or this formula we are calling as the derived physical. This we are calling as dimensional formulas. Okay, students, once again. The dimensional formulas means the formula which contains the fundamental quantities which are with exponents, the suitable appropriate exponents. This formula we are calling as dimensional formulas. Okay, students. So this is the dimension. This is the dimensional formulas. Once again, we can recapitulation about the dimensions. Dimensions means the exponents, the powers of the fundamental quantities are called dimensions. And dimensional formulas means the formula which containing the fundamental quantities with their proper dimensions. Dimensions means proper exponents is called as dimensional formula. Okay, students. Then let's see some examples. Let's see some examples of the dimensional formulas. Dimensional formulas. First one is for suppose speed is there. Speed is the derived physical quantity. What is of its general formula? Distance by time. As you all know this, distance by time. So in the letters short we can write as a V is equals to S by T. Okay, students. Then this is the general formula. Then what is of its dimensional formula? Dimensional formula dF is equals to, or dimensional formula of the speed is, what is the dimensional formula of the distance? Distance is nothing but length only. Okay, na? Then L1 by, what is of its dimensional formula of the time? T1. Okay, then L1, send this t plus 1 from denominator to numerator, it becomes to the t power minus 1 or sorry. So dimensional formula of the speed is L1 t minus 1. So, or we can represent this dimensional formula of the speed is one more way also. What is that? Dimensional formula of the speed is, okay, now generally the dimensional formulas are which are represented in terms of the fundamental physical quantities only. Means what are those? M, L, T, K, I or A, etc. Okay, students. Okay, candela, CD and mole. So generally most of the physical quantities can be ending by this MLT only. Okay na? So remaining factors also which are introducing, which are adding to there, that depends upon the requirement. Okay na? That depends upon the general formula and requirement. We can use this remaining letters also, letters of the fundamental quantities also, but most of the physical quantities can be ending by these three letters only because of, see here, L1. What is the dimensional formula of the speed? L1 t minus 1. So if you want to represent this dimensional formula of speed in terms of the MLT, the what is the missing here? What is the missing here? What is omitted here? Just only mass. Means in the powers, in the power of the mass, if you put the 0, then which is a representation in the form of MLT. Means M0 L1 t minus 1. Don't call it as the M power 0, L power 1, t power minus 1. Don't call like that. Just only we have to read it as a M0 L1 t minus 1. Okay, students. So the dimensions may be in the power, the dimensions may be in positive or negative. Okay. So some values which are in a positive, some values which are in a negative also. Means the dimensions completely we can understood. The dimensions finally we can represent, we can get in terms of the positive values or negative values. So the next one is this is speed. Or suppose if you see the sorry, acceleration. Okay, students. Acceleration dimension formula. Let us find out now. Acceleration. What is the dimensional formula? What is, if you want to find out the dimensional formula of the acceleration? First we should do the general formula of the acceleration. Okay. What is that? V minus u by t. Students, here we should remember one thing. If you are going to find out the dimensional formula of anything, the same quantities, we can consider it as a single quantity only. Means final velocity minus initial velocity. If you subtract these two things, again you get the velocity only. That's why we can consider only the simple single velocity by time or speed by time. That A is equals, already we found the dimensional formula of the speed. What is the, students, here? M0 L1 t minus 1 we got here by what is the dimensional formula of the time? T1, that is equals to M0 L1 t minus 1. Again if you send this 10 power plus t power plus 1 from denominator to numerator, it becomes to the 10 power minus t power minus 1, then t minus 1 into minus 1, that is equal to 10 t minus 2. Means M0 L1 t minus 2 is the dimensional formula of the acceleration. Is it clear, students? So this is the end. Like this we can find out, like this we can find out that dimension and dimensional formulas of every physical quantities. So here what are the dimensions here? Dimensions of the acceleration, 0 plus 1 minus 2 are the dimensions of the acceleration. Here 0 plus 1 minus 1 are the dimensions of the speed. Here what is the dimension of length in speed? Plus 1. What is the dimension of time in speed? Minus 1. What is the dimension of time? What is the dimension of time in acceleration? Minus 2. What is the dimension of mass in acceleration? 0. What is the dimension of length in acceleration? Plus 1. So like that we can find out that dimensions and dimensional formulas of every physical quantities and physics. Okay, students. So we can discuss, we will discuss about the remaining concept, means what are the advantages of this dimensions and dimensional formulas in the next video. Okay, with the proper examples and proper problems. So this is end of today's class. And if you like this video, please share, like this and comment on these videos. And don't forget to subscribe this video channel and please click on the bell icon for getting the first notification. This is end of today's class. We'll take it in the next video. Have a great day. Bye.